Hey everyone, I hope you're doing well today. In this video, let's practice solving one-step equations. Specifically for this video, we're just going to practice solving equations that only have addition. To solve each of these one-step equations that have addition as the operation, we're going to need two main properties. First, since each of these equations have addition in them, we're going to have to use the subtraction property of equality to solve each of them. And second, once we're done subtracting, we're going to use the identity property of addition to simplify the equation down. Let me show you real quick the different types of examples we'll cover in this video. First, we'll start off with a couple of these, then we'll try a couple of these, here's a couple more, then we'll get a little fancy with some more fractions and decimals, and we'll finish up with these two. In all 10 of these one-step equations, notice how the only operation in all of them is addition. Before we get into solving a bunch of these one-step equations, you could really help out this channel in one step by just clicking that like button. Believe it or not, by doing so, you're really helping this channel continue to grow and help more and more people. That being said, I encourage you to grab some paper, something to write with, and let's do some math together. For this first example, let's go ahead and solve the equation x plus 9 is equal to 2. To solve for x, we first want to notice that we have an operation of addition here and we're adding 9 on the left side, so to isolate x, we're going to go ahead and subtract 9 from both sides of this equation. By subtracting 9 from both sides of the equation, we're using the subtraction property of equality. By specifically subtracting 9 from the positive 9 above it, we're going to get 0, so we're going to have x plus 0 on the left side of the equation. On the right side of the equation, we have 2 minus 9, and since 9 minus 2 is equal to 7, then 2 minus 9 is equal to negative 7. Because adding 0 doesn't change any values, the identity property of addition states that we don't need to write the plus 0. We can just write that x equals negative 7. There's our solution. For example 2, let's try solving the equation 13 is equal to 7 plus w. Once again, we have this addition sign, but also note that we have a positive 7 over here. Because we're solving for the variable w, we need to get rid of this plus 7. To do that, we're going to subtract 7 from both sides of the equation. By doing so, we're using the subtraction property of equality. On the left side, 13 minus 7 is equal to 6. On the right side of the equation, this plus 7 and minus 7 will combine to make 0, and we'll have 0 plus w on the right side. Using the identity property of addition, we can go ahead and just drop that 0, and we can write that 6 is equal to w, or if you want to turn it around, you can also write that w is equal to 6. There is our solution. For example 3, let's solve the equation 5 is equal to 14 plus y. Notice the addition sign over here and that this 14 is positive. To solve for y, we need to isolate it and get rid of this plus 14, so we're going to go ahead and just subtract 14 from both sides of the equation. This right here is the subtraction property of equality. On the left side, we have 5 minus 14, and if we know that 14 minus 5 is equal to 9, then 5 minus 14 is equal to negative 9. On the right side, the plus 14 and minus 14 combine to make 0, so we can write 0 plus the y along the right side of the equation. We can go ahead and drop the 0 from the identity property of addition, and finally we can write negative 9 is equal to y, or turn it around and write that y equals negative 9. There's our solution. For example 4, let's try solving the equation 12 is equal to 17 plus p. Our operation is addition, and the 17 is positive, and to solve for p, we're going to have to go ahead and subtract 17 from both sides of the equation to get p alone. On the left side, to figure out what 12 minus 17 is, think about what 17 minus 12 is, and since that's equal to 5, then 12 minus 17 is just equal to negative 5. On the right side, the plus 17 combines with the minus 17 to get 0, so we have 0 plus p on the right side of the equation. Since adding 0 doesn't do anything, we can get rid of it using the identity property of addition and write that negative 5 is equal to p, or we can say that p is equal to negative 5. There's our solution. For example 5, let's go ahead and solve the equation a plus 11 is equal to negative 6. To solve for the unknown variable a, we need to take a look at this plus 11 and know that we have to subtract 11 from both sides of this equation. By specifically subtracting 11 from both sides of the equation, we can simplify the left side of the equation to a plus 0. And on the right side of the equation, we have this negative 6 take away 11, and when we take away 11, it has to get smaller. So negative 6 minus 11 should equal negative 17. This is where we use the subtraction property of equality. And over here, when we go ahead and drop that 0, we're using the identity property of addition. After dropping that 0, we can write that A equals negative 17. There's our solution. For example 6, let's solve the equation b plus 4.3 is equal to 9.1. To isolate the b, or to solve for it, we're going to have to see this plus 4.3 and go ahead and subtract 4.3 from both sides of the equation. Don't let the decimals scare you any bit, it's just the same thing, just with decimals. On the left side of the equation, this plus 4.3 and minus 4.3 will combine to make 0, so we can write b plus 0 on the left side. On the right side of the equation, 9.1 minus 4.3 is equal to 4.8, so we can write that on the right side of the equation. Subtracting 4.3 from both sides of the equation was using the subtraction property of equality, and then going ahead and getting rid of this plus 0 that we're about to do right now is using the identity property of addition. Simplifying this down, we can just write that the value of b is equal to 4.8. There's our solution. For example 7, let's try solving the equation c plus 0.8 is equal to negative 7.7. To solve for c, notice how we have this plus 0.8, so we're going to go ahead and isolate c by subtracting 0.8 from both sides of the equation. Over on the left side, this plus 0.8 and minus 0.8 will combine to make 0, so we can write c plus 0 on the left side of the equation. On the right side, this negative 7.7 take away negative 0.8 should get even smaller, and that's going to equal negative 8.5. When we subtracted 0.8 from both sides of the equation, that's using the subtraction property of equality, and in just a moment we're going to drop the 0, and that's using the identity property of addition. By dropping that 0, we can write that c, or 1c, is equal to negative 8.5. There's our solution. For example 8, let's go ahead and try solving the equation d plus 3/4 is equal to 7/8. Now, while I know that fractions can be a little bit intimidating, try not to worry too much. This whole process is going to stay the same, just with fractions instead. To isolate d, we see this plus 3/4, and we're going to go ahead and just subtract 3/4 from both sides of the equation. On the left side, combining the plus 3/4 with the minus 3/4, that's going to combine to just make 0, so we can just write d plus 0 on the left side. On the right side of the equation, we need to take away 3/4 from 7/8. And I know this is really annoying, but we need to take a look at these denominators and find common denominators, and we can do that by finding the LCM, or the LCD. Now, 4 and 8 meet at 8 for the first time, so we can go ahead and just multiply that 3/4 by 2 over 2, and it's going to become a negative 6/8 instead. Same value, just different denominators. So if we were to go ahead and take away the 6/8 from the 7/8, that's just going to equal 1/8. We can say that d plus 0 is equal to 1/8. If 7/8 minus 6/8 is equal to 1/8, that means that 7/8 minus 3/4 is also equal to 1/8. When we subtracted 3/4 from both sides, we were using the subtraction property of equality, and when we're about to drop the 0 over here next to the d, that's going to be the identity property of addition. At the end of the day, we can say that d is equal to 1/8. There's our solution. For example 9, let's try solving the equation e plus 2/3 is equal to 3/4. To solve for the variable e, we take a look at this plus 2/3 that's next to it, and let's go ahead and subtract 2/3 from both sides of the equation. This plus 2/3 and minus 2/3 will combine to make 0, so we can write e plus 0 on the left side of the equation. On the right side, we need to take away this 2/3 from 3/4, but we need common denominators. Taking a look at this 4 and this 3, the first time they're going to meet is going to be at 12, so we can get to that common denominator of 12 by multiplying the 3/4 by 3 on top and bottom, and multiplying the 2/3 by 4 on top and bottom. Rewriting these fractions, we really have 9/12 take away 8/12. Taking away 8/12 from 9/12, we find that 3/4 minus 2/3 is basically just 1/12. When we subtracted from both sides of the equation, we were using the subtraction property of equality. We just needed to get common denominators first, and when we got the 0 here, we can drop it in just a moment. That's just using the identity property of addition. Finally, we can say that e is equal to 1/12. There's our solution to this equation. For the 10th and final example, let's try solving the equation f plus 5/6 is equal to -1/2. To solve for the variable f, we're going to take a look at this plus 5/6 that's next to it and go ahead and subtract 5/6 from both sides of the equation. On the left side, this plus 5/6 and minus 5/6 will combine to make 0, so we can write f plus 0 on the left side of the equation. And on the right side, we're going to have to take away this 5/6 from the -1/2, but we're going to need common denominators first. So 2 and 6, their LCM or LCD, is going to be 6. We can just multiply this -1/2 by 3 on top and bottom, and this is going to be equal to -3/6. That's just the same fraction. And for the -5/6, well, that one doesn't need to change. You could multiply by 1 and 1 if you want on top and bottom, but we can leave it as -5/6. Taking away 5/6 from -3/6, that's just going to be -8/6. When we subtracted 5/6 from both sides of the equation, we were really just using the subtraction property of equality, and dropping the 0, we're using the identity property of addition. Dropping that 0, we can write that f is equal to -8/6. Simplifying this and dividing the numerator and denominator by their GCF, we can go ahead and say that f is equal to -4/3. This would be the most simplified version of the value of f. If you want to also write it as a mixed number, go ahead and do so and write f is equal to -1 1/3. That's also totally okay. And there you have 10 different examples on solving one-step equations that have addition by using the subtraction property of equality and the identity property of addition. If you found this video helpful, you can go ahead and let me know in the comment section below or just by clicking that like button. Thanks for watching, and as always, keep up the great work, and I'll see you in the next one.